Hello and welcome to the YouTube channel The Intellect Zone. So this is the first video, or rather the first chapter of the subject computer science that we will be going through in the OLevel computer science lecture series. In order to obtain a proper understanding about our OLevel computer science lecture series, make sure to go and watch the OLevel computer science introduction video that we have uploaded in our channel. So without any further ado, let's hop into it. Chapter 1 is named Binary Systems and Hexadecimals. The diagram above showcases the subtopics that we will be going through in this chapter. The first subtopic is named the binary system. A binary system is a base 2 system, which means its values are made up of 2 to the power x values. The binary system only uses zeros and ones to represent digits. As you can see in this diagram, zeros or ones are assigned to the 2 to the power x values. The most fascinating, or rather the unique thing about electronic devices is that they operate in binary. We find it hard and intense to understand the binary system since it can cause many errors during usage. The next subtopic is named the denary system. A denary system is a base 10 system, which means its values are made up of 10 to the power x values. We find it easy to understand and use the denary system. The hexadecimal system is the next subtopic. It is a base 16 system, which means its values are made up of 16 to the power x values. This system is used to simply represent the binary system. It is easier to use the hexadecimal system than the binary system. The diagram below presents the various concepts where the hexadecimal system is used. HTML, or the hypertext markup language, is the next subtopic. It is a web authoring or a markup language. A web authoring language is a web or website development system that allows to create web pages visually. It uses tags to separate pieces of codes from each other. The next subtopic, HTML code, is made up of a variety of values. It is the HTML code that represents the colors of text which are displayed on a mobile or computer screen. RGB, or the colors red, blue, and green, are the 3 prioritized colors. The example below shows how different numerics, letters, and symbols are used to create various colors. The next subtopic, the MAC address, or the Media Access Control address, is a unique address which recognizes a device on the internet. The structure of these types of addresses are made up of 6 groups of hex or hexadecimal digits. The pattern which is shown in the screen is a sample of the structure of a MAC address. The N values represents the identity number of the manufacturer of the device. The D values represents the serial number of the device. A serial number is a unique number that identifies and separates a specific product from others of the same type made by the same manufacturer. Off we go to the next subtopic, the web address. A web address contains information and transfers a user to a set of web pages. It is also called as the URL, which is the Uniform Resource Locator. Speaking of URLs or web addresses, go down to the description box and click the URL or the link which is attached to it. This link will direct you to our official website, where you will be able to download notes for various subjects free of charge. And also you will be able to understand the purpose and many more about our YouTube channel. Just go, press that link, and become an active member in our educational community. Off we go to the next subtopic, memory dumps. The process of taking all information content in RAM and writing it to a storage drive is known as a memory dump. This simple definition is the only thing that you have to study under memory dumps, if you are an OLevel student. Assembly languages and machine code is the next subtopic. Both of these languages are low-level languages, which means they can directly refer the computer memory. You will learn a lot more about these languages in the 7th video or the 7th chapter of our OLevel computer science lecture series. Off we go to the last but not the least subtopic, conversions. What we mean by conversions is simply actions which are taken in order to convert one system to another. Here we will talk about 6 of these conversions. The first conversion is the conversion of binary to denary. This value is the binary value. These values are the 2 to the power x values. What you have to do is simply assign the zeros and ones to the 2 to the power x values each. Then add together the values which are assigned to 1. Here it is, 32 plus 16 plus 2 plus 1, which gives us 51 as the denary value. The second conversion is the opposite of the first conversion. The conversion of denary to binary. You can do this via 2 separate methods. 170 is the denary value. Method 1, here the exact same thing occurs. You write down the 2 to the power x values and assign zeros and ones in order to get the value 170. The values which make up 170 are 128, 32, 8, and 2. You place ones for these values and zeros to the rest of the other values. Method 2 is where you divide 170 by 2. You obtain the remainders and read them from top to bottom in order to obtain the denary value. The third conversion is the conversion of binary to hex. A principal rule was created in order to further simplify the use of hex values. The diagram on the left is this principle. As you can see, for the numbers from 10 to 15, alphabetical letters, A to F are assigned. Now let's talk about this conversion. Start splitting from right to left, and add zeros from your left, if the last group does not have 4 digits. Then use the 2 to the power x values, which represent the zeros and ones, to obtain the hex value. For example, the first group represents the value 11, so you use the hexadecimal principles and assign B to represent 11. You do this to all groups of 4 bits available to obtain the hex value. In the next conversion we convert hexadecimal value to binary. Here the exact opposite happens to the previous conversion. We take each hex digit and write down the 4-bit code which corresponds to the digit. Here, 45 AB is the hex value which we convert into 4 groups of binary values, in order to obtain the final result. The next conversion is the conversion of hex values to denary. Follow the steps below, and you'll realize that a base 16 system is used here. As you know, this is since the hexadecimal system is a base 16 system. Obtain the multiplied values and add them together to obtain the denary value. The last and final conversion is the conversion of denary to hexadecimal. Here we divide the denary value by 16, obtain the remainders, and read them from top to bottom, to obtain the hex value. Well, these are all the conversions that you may have to follow. To get the hang of it, make sure to do past paper questions where conversions like these are present. All these concepts that we discussed on this video are of chapter 1 of this subject. To get a better idea of this subject, go and watch the Introduction to Computer Science video that we have uploaded under the OLevel Computer Science lecture series. That's basically it for this video. Thanks for watching. And as always, enjoy your presence in this intellectual zone.